Okay, so like we said at the beginning here, algebra is sort of the basics and the fundamental of physics. Okay, learning how to manipulate an equation to get a specific variable is like a cornerstone of physics. Now, the reason why that's the case is because in physics, we really focus in on the interconnectivity between variables. So when I'm thinking about something like speed, I'm not just looking at just speed, right? I'm looking at what's involved with speed, like distance and time. And so I can use speed and distance to get time. I can use distance and time to get speed. I can use time and speed to get distance. All of that is connected. So to be able to quickly and efficiently isolate for variables is one of the key skills. So what we're going to do is I'm going to write isolate for x in the following. Okay, I'm going to give you a series of equations here, and we're going to isolate for x. And again, there's no correct way to do this necessarily, as long as you're getting the right formula in the end. So I'll start off with this. We're going to go v is equal to x t. Okay, we'll start off with these two here. So take a minute or so and see if you can get the x by itself. So x equals what? Okay, so I did the first one here. And again, if you did it a different order, that's fine, as long as your final formula looks like this. So remember that in math, a dot is a multiplication sign, right? Because we're working with x's, if we do just the typical x as a multiplication sign, it gets confusing with the x variable. So we write a dot. So t was on the bottom here. I wanted to move it to the other side to isolate for x. So I just multiplied both sides by t, and it ended up with x is equal to v times d. Okay, now this one, I'm going to work through it step by step here. If you did it a different order, remember that is okay, as long as your final answer looks the same. So for me, I like to remove fractions and remove the denominator because I find they just complicate things when we keep them at the very end. So right now, it's a is equal to x minus b divided by delta t. Remember, the triangle just signifies change in t. So I'm going to isolate or get the x by itself. To remove the denominator, remember it's the same thing as being divided by delta t. So inverse operations, we're going to multiply both sides by delta t. And then that's going to cross this out. What that leaves me with here is a multiplied by delta t is equal to x minus b. And then I want the x by itself, so I'm going to remove the b over here to the other side. To do that, I'm going to do inverse operations. So I'm going to add b, well, I put a 1 here, sorry. And that'll get the minus b plus b gets rid of that. And so my final formula is going to be a times delta t plus b equals x. And that should be the final formula that we have here. Again, if you did v plus a times t, that's also the same thing. Okay, there's no difference in that as well. So either one of these would have been right. If you did it a different order, that is okay, as long as the final formula looks like one of these two. Again, we're still solving for x. And we're going to go a is equal to v2 minus v1 over x. I want you to take a minute, carefully isolate for this here. Okay, so I did what could be deemed as a little bit of an unusual move. Remember, for me, I like to get rid of the denominator. Even if I'm trying to solve for the denominator. And the reason why is because I can do it or deal with it in another step. What I've done here is I made a linear equation. So the x, which I'm solving for, isn't the denominator. So in order to remove the denominator or place it to the other side, just multiply both sides by x. And what that does is that cancels x out on this side, but then it brings it more importantly over here. So then I'm left with a times x is equal to v2 minus v1. Well, in this case, it's very simple. If I just want to move, or if I just want x to be on the left side only, I only have to get rid of the a. So I'm going to divide both sides by a. I put the x over here, right? So now I don't have a denominator or a fraction. And then I divided both sides by a. And then finally, my final formula for x ended up being x equals v2 minus v1 over a. Y is equal to half x squared. And I'm solving for x. Okay, so I'm going to do this one with you guys to show you one way of doing it, right? But if you do it another way, that's also okay. So some people, they would change this to a decimal and they would rewrite it because fractions give people anxiety. So they would rewrite it as y equals to 0.5 x squared. And once they got that is at a decimal, the goal is to get x by itself. So you would divide both sides by 0.5. Because right now it reads as 0.5 times x squared. And so I got y over 0.5 equals x squared. Now, some people might mistakenly look at this and say, I've got x, that's it. Now, do I have x? I see a head shaking here. No. Okay, I don't have x just yet. Oops. So I have x squared. So what I need to do to get rid of that exponent is do what? How do you remove a square? The root. That's right. Take the root of both sides. So we're going to go the square root here and the square root here. Now, when you're doing this, remember to put the entire left side under the root. Okay? And then what happens in math is the root and the x and the squared on the x, they cancel each other out. And so my final formula, and I'll write this in blue, ends up being x equals root y over 0.5. Okay, the final thing here. And again, we're going to practice all this on the worksheets, right? So you have x squared minus 7x minus 18, and I want to get x. So I'm going to underline something here. Whenever there's an x squared and an x, does anybody remember what kind of equation is this? Trinomial, that is correct. Okay, raise your hand if I say this term, if it's, if you have a, oh yeah, kind of moment. Factoring trinomials. I'm going to give you guys a minute to kind of work through this if you can remember how to do it. And if you can't, I'm going to totally go through this or completely go through this anyway. Okay, so take a minute and then we'll go through the steps and that'll be the final one for today. Okay, so Again, if you're still working on it, that's totally fine. Just check and see if you got the same thing here. So this is a trinomial. It's got 3 terms. And there's an x squared and an x. There's 2 different degrees. So what we're going to have to do, the only way to get the x is to factor it. And we're going to factor it using a method called grouping, right? So I'm going to erase this here, trinomial. And the first thing I'm going to do, remember that there is always an invisible one in front of a variable that doesn't have a coefficient in front. So the first thing we do is we multiply the first and the last terms. So that would be a 1x squared multiplied by negative 18. That gives us negative 18x squared. The second thing we're going to do is we're going to list all the factors of negative 18. Okay. Now remember, you can also go negative 18 and 1, negative 9 and 2, and go backwards as well, but that's fine. Now we got 3 sets of factors to choose from. We're only interested in the pair that when we add them up are going to give us the middle term of negative 7x. So in this case, and I should also add, sorry, that each one of these would have an x, right? Because x times x would give us that x squared over here. So if I choose 2x and negative x, if I add those 2 together, that does give me negative 7x, which is exactly what I want over here. So the second part here is that I've grouped this equation, or I've picked my factors, sorry. Now the third step is going to be the grouping. And what that means is I'm going to separate these 2 factors into 2 different parts of the equation. So I'm going to pair the 2x with the first part, which is the x squared. We're going to go x squared plus 2x. And then the next part, minus 9x minus 18. So instead of writing minus 7x, we're expanding minus 7x into 2x plus 9 plus minus 9x, or just 2x minus 9x. Okay, and then from here you group, which means we're going to factor each one of these out separately. So between x squared and 2x, what's a common factor? Something I could pull out?
X?
Yep. Yeah, excellent, Harun. It's x. So I'm going to pull x out of here. So I'm going to x. And then remember, when you're pulling out, what you're really doing is dividing each term by x. So x squared divided by x gives me x. And then 2x divided by x is going to give me 2. So I got x bracket x plus 2. All right, what about the next equation? So I got minus 9x and minus 18. Is there something I can pull out of both of them? Negative 9 more specifically, right? So Abdu's saying we could pull out negative 9. Excellent. So when I go negative 9x divided by negative 9, because that, right, pulling out means to divide by, I'm left with x. And if I go negative 18 divided by negative 9, I'm left with what? I'm left with positive 2. Excellent. So I got x bracket x plus 2 minus 9 bracket x plus 2. The final step. Does anybody remember where to go from here? Fourth part here. I can see that there's something that shows up twice. Anybody know? Yes, so I'm just saying it right. So I'm just saying, well, now each of these terms, because this is one term and this is another term, each of these terms have x plus 2 in common. So you can actually factor that out. So if I factor x plus 2 out of each of these, which means I'm dividing by x plus 2, I go x plus 2, I'm pulling it out. Well, what's left? I go x times x plus 2 divided by x plus 2, I'm left with x. And if I go negative 9 bracket x plus 2 divided by x plus 2, right, then I'm left with negative 9. So now I got 2 solutions, x plus 2 and x minus 9. And when you have a trinomial like this, you are going to have two solutions for x. Based on the problem, you just have to figure out which one you're going to accept or reject. But in this case, we have no reason to reject any of them because it's not related to a problem just yet. Now, last thing I want to make mention here, if I write, okay, well, then what does x actually equal? Remember that each bracket is set to what? Anybody remember? That really, each bracket is set to 0. So you would really rewrite this as x plus 2 equals 0 and x minus 9 equals 0. Which means, okay, if I want to find out what x actually equals, for x plus 2 equals 0, what does x actually equal? Yeah, so x actually equals 2 because, or negative 2, sorry. X equals negative 2 because in order to isolate for x, I would subtract both sides by 2, right? So 0 minus 2 would be x equals negative 2. Or x could equal, if I got x minus 9 equals 0, then I go plus 9 and plus 9. And so it would just be x equals 9.